打开这个。Okay, good morning, everyone. And it's I think it's very happy for me to see all of you here online. And first of all, I should say thanks given to Professor Bambang Sumintono, head of the PhD in Education, Faculty of Education, University Islam International, Indonesia, to give us such a chance to strengthen academic exchanges. Okay. Can you see? Can you see the PowerPoint?
Not yet.
Oh yeah, now
Okay.
it's okay.
Yeah.
Okay. Again,
All right. So we only see the what we call as the browser, not the not the PowerPoint, not the slide.
这不是这个，这是背景墙上的，不是。It's okay?
Yes, now.
It's okay?
Showing now.
Okay. Can you see?
Excellent. Yes, yes.
Yes,
We can see that.
see, sir.
Okay. Everyone can see the PowerPoint slides.
Sure. Yes. Correct.
Okay.
Positive.
Again, I should say again, okay. First of all, I think so thanks given to Professor Bambang Sumintono, PhD, head of PhD programs in education, Faculty of Education, University Islam International, Indonesia, to give us such a chance to strengthen academic exchanges, you see. And my topic today is item analysis, test equating, you see. And all the ideas presented here are actually based on this book. This is my newly published book by Taylor and Francis. So next time when we have the prompts, Professor Bambang, I can give you the book, not the proceeding. This is my monograph, you see. So today I just want to share the ideas with you, published in the book. Okay. So this is item analysis test equating.
Item analysis and test equating in the age of AI.
And the lecture falls into 3 parts. And in the first part, I just give a brief introduction to the background, the research of the background. And I don't want to say too much about Rush model because you have excellent advisor, you see, Professor Bambang, who will tell you more about the Rush model. So I will briefly say something about the background to research. And then I will focus on 2 important parts, the 2 important aspects of language testing. One is item analysis, the other is test equating. And item analysis addressed here is based on classical testing theory, and test equating is based on Rush model. Excuse me, could you hear me? It's okay. Okay.
Yes.
Okay. And then we'll demonstrate the newly with the updated software, means to demonstrate the whole process using the data to demonstrate the whole process from item analysis to test equating to get all the results, and then we can interpret all the results. So if possible, then if we have time, then we can have question and answers. So that's the 3 parts we shared this morning for my lecture. And personally, I briefly I would say in China, and briefly I should say, you see, I was actually in charge of conducting test equating for 10 years, because at that time in China, we have a 10-year MET equating project. MET means matriculation English test for higher education entrance examinations. It's high stake. And that's from, okay. And from 1990 to 1999, only 10 years. So I conducted this very big project for test equating. And also, personally, I also run workshops, pre-conference workshops since, we say, 2021 at, we say, PROMS conference in the Pacific Rim Objective Measurement Symposiums, you see. And also, it is at the PROMS, I met, you see, Professor Bambam. Well, I think he's the excellent and professor in Muslim countries, you see. And also, I'm the editor of PROMS conference proceedings. We publish conference proceedings each year after conference was held. So I sincerely hope that all of you will attend the conference, because next year's conference will be in China, or we will be a host the conference again. Then we developed them. You see, the most updated computer software is a Rush-based software. It's called Rush Guangzhou. Okay. So let's come to the first part, introduction. And I say there are two important aspects in language testing. One is item analysis, usually based on classical testing theory. And then we have test equating based on Rush model. So what is item analysis refers to, you see? And what purpose of conducting item analysis? So I should say, you see, item analysis ensures the good quality of test items to provide possible or objective feedback to test item designers or writers, so that to better moderate or improve the test item design and item production based on test data. So if all of you, or some of you, or all of you are writing test items or conduct test, we say writing test items for your students, or administer any test papers. So I think test item analysis is very important. So we can ensure the good quality of test items. Okay. And also, by, you see, conducting test items, we can reduce personal or subjective factors, you see, among test item writers, while we moderate test items. So, you know, if we have a test paper, you see, and people or you may discuss with your counterparts or with your colleagues, you see, sometimes or most often, we may have some dispute over some test, the design of test items, or we say this is good, which is good items. The other say no, it's not good, it's easy. So it means you have a lot of argument. But that argument usually is based on, you see, your subjective or personal opinions. So with item analysis, we can, you see, I say, to use the parameters you see, obtained from the computer, the software, so we can easily solve any problems, you see, or dispute, okay, because that will be more objective. Item analysis based on objective data, especially, or in our software, we can, you see, produce or use overall reports about the appropriate portion regarding test item difficulties assigned to each section of a test paper, and indicate which items are good and which are not. Especially, you see, we have the parameter of what we call discrimination index, you see. So that's all the, you see, items we have for item analysis. They are based on classical testing theory. You see, this is a simple one. And for, you see, item analysis, I think this is important. It means discrimination index. This is very good or important, we say, parameter we use to judge whether the test item is well designed or not. Okay. Then we have some school needs courtesies, and then we have difficulties. So that would be that's the two ideas of item analysis. And we use our software, we can generate, you see, each of these parameters for each test items. Okay. Then for test equating, I should say, before we come to the test equating definition, I think I will show you some simple ideas about what we mean by test equating. 就把那个基本的文件放出来，就昨天给你的一个基本文件。OK， 有想法你记那个泡泡。Okay. Some basic ideas. For example, you see, for I show the ideas here. Now, if we have two groups of students, if we have two groups of students and they take one test paper, very easy for us to know after testing, we will know which group of students is good, which is better. You see? So in the case that two different groups of test takers take the same test paper, we would easily get to know which group of the test takers is better once we collect the data and work out the scores. That's easy. Everybody knows such ideas. Or in some other cases, we have only one group of students, and they will take two different test papers. You see the point? So after the administration of test papers, we will easily know which test is easy, which is difficult, because they're based on the same test takers. So this usually in language testing is what we call a common subject equating. That's also easy. But for test equating, usually we have the very different situations. We have test groups A, for example. They will take test A. Then we have test groups B. They will take test B. Because we cannot use the same test paper repeatedly to the same group of students. So that's why usually we are designing, you see, different test papers to administer to different group of students. You see the point? So now we are facing test equating because you see, for example, this year's students take test A and next year's students take test B. We have to compare which test is easy or is appropriate for our students. And also we have to know which test takers are good or better. So this is the idea of what we call test equating. And this practice of test equating is conducted every year, you see, by most we see the language testing services on the big important testing services like ETS in the United States or in the other in UK and also in China. We still have such practice each year. So as to ensure test fairness. You see the point? Otherwise, you see, for example, in China, we have the MET test. So because this is the most important and influential examinations and attended by, we say now it's over, 10 million students. So we will ensure the stability of the test item difficulties, you see, so that will be offer the fairness, to ensure the fairness of the test practice. Okay, so that's the idea of test equating I'm going to talk about today. This is more important. And for test item analysis, that means we should have very good or well-designed test items. Then we can do, based on the test, the well-designed test items, so we can make test equating, we say, meaningful and appropriate. So in doing so, and usually we establish some linking items between, you see, all different test papers. Or we say this is a parallel test. We'll have the linking items put in both or in the following these test papers so that we can ensure that we say the good, we say analysis of the test item difficulties. So that's the that we say the ideas. Now let's go on. Okay. Okay. So test equating, we should have a design. So the concept of test equating discussed here refers to linking of test forms through common items or linking items so that scores obtained or derived from the tests which were administered separately to different test takers on different occasions after conversion will be comparable on the same scale. This is very formal definition of test equating. And this is the given by the Hamilton and Swaminathan. They are working at ETS, you see. And also you can find, you see, the similar definitions in the other books about testing, language testing. So why to conduct test equating? So test equating ensures test fairness and security. So that the scores obtained from different parallel test papers can be comparable on the same scale. Means after conversion. Okay. So how to conduct test equating? So this is very important. So usually most people know the ideas or the definitions of test equating. So as to how to conduct specifically this test equating, we must use different softwares or the language testing specific softwares. So in this world, or usually in today's world, we have several. You see, usually people use Bilog or Pascal or WinSteps. You see, WinSteps are WinStep is rush based, but it's personally speaking, it's difficult for you to write to conduct test equating using WinStep because you have to first write a control file. You see, or we say a command file means actually you have to write a small programs, then tell the computer how to do the test equating. So this is some way for the students, for example, Chinese students of English, for Chinese students of humanities or management. So they think it's difficult, okay? They are lack of both the computer programming knowledge and also language testing, principles and so on. And then in the past, we use KeyTest. That's the programs we did. First, we developed we say probably 25 years ago. Yeah. But that's very simple. You see, this, program was written in BASIC. Was written in BASIC, and can only process a small sample of data. And also everything, the parameters or interpretations generated in the output files or in English. Okay. So, and here you see, we update this software then this software is actually written, you see, in the network language. So it can work online. It can process, you see, unlimited number of items by an unlimited number of, you see, subjects. So and also easy for you to operate, because you see you needn't write any, you see, command file or control file. You just press button. We have given you the menu. You just prepare the data and press button, then you can get results. You can you can get all the results, and also the results in the output files, maybe in English or in Chinese, or today we also prepare in the Indonesia language. So that's easy for you to use it. So, and also the instruction is in Indonesia, can be in the spoken mode, and also can be in the written mode for you to use it. So that will be easy. Later on we'll demonstrate it. Okay. So research background, you should say just a few words about this, you see. Of all the objective measurement approaches that are at the disposal of researchers and practitioners over the past centuries, Rush model is the most versatile, powerful, and feasible. You see, its versatility comes from the way in which it enjoys increasingly application to a wider range of research fields, ranging from the social studies, electronics, behavioral, and health science, a means in performing item analysis, testing scoring, and equating language testing. So Rush model, I should say, can be used in almost all the research field, you see, or in the research field you are now actually conducting. So that's the Rush model we are going to use. The power of Rush derives from the way in which it enables researchers and practitioners to construct variables so as to produce objective measurement or to provide an adequate explanation for the solution to their problems. The feasibility of Rush lies in the data metrics, either dichotomous or political. Yes, for example, the Biolog and the software we developed, we use dichotomous data. That means, I think, yes or no, or dichotomous data means the yes or no data, or polytomous data, such as the Pascal we mentioned. You see, Pascal can process polytomous data because they can process the data of 6 categories. You see, from 1 to 6. You see, so with a click of mouse, now we use computer software, all the results will be especially endcode generated and saved in the designated file for further use. That's easy and fast. And we use Rush model, you see, because you see, I said I don't want to say too much about Rush model because I presume that with, you see, Professor Bang, you see, serve as the PhD supervisors here. I think you know more or less, you see Rush model. So I'll just say Rush model is one simple yet old model for conducting assessment, and that's the formulas we use. This is also a formula we use in our program in Rush the fields. Okay. Today the model is held as Rush model among measurement professionals and testing practitioners, believed to have insulated the vision of promoting objective measurement and to have contributed greatly to scientific discovery. Okay. However, I should say that's in China. You see, however, such a versatile, powerful, and feasible approach is mostly confined within a small professional groups of prompts. And also in China, you see, the understanding, the dissemination, and the beauty of which are never fully experienced or shared by a majority of researchers in other fields. You see, in China, you see, only language testing professionals, or some scholars of management, or the some researchers in the examination bureaus, they are familiar with Rush model and the Rush-based computer softwares. So furthermore, up to present, you see, WinSteps is the only software program mostly used to process data metrics or to conduct test equating. You see, of course, we have the other softwares that is, one is called Run. You see, Run is also one, and Bilog, I said, but they need to write control file, and you see the we say our command files. So that's why we are motivated by this. We have managed to write our own program called Rush Guangzhou just right before the COVID-19 pandemic period, you see, and to meet the ongoing rapid development, you see, incorporated with AI, you see, especially incorporated with artificial intelligence. So our software is easy to use. It is a multilingual with multilingual functions. You see, for Indonesia people, today we just use Indonesian language, okay? And with emphasis on two important aspects for language testing. See, we have item analysis based on classical testing theory and test equating based on Rush to further develop the online use of Rush so as to be well geared with international practice. So that's why if we use software online, so we can have direct, you see, communication or exchanges, okay? So our goal is to develop Rush Guangzhou and publish books that would give Rush community a general picture regarding Rush measurements conducted in the context of language testing. So the past 3 years, we took, you see, 3 years. It took 3 years for us to complete this software. So in what follows, I will give a brief introduction to Rush Guangzhou, and then we demonstrate the software with data, you see, to illustrate the ideas presented above. After that, we'll be happy to have questions and answers from our participants. And by the way, have you downloaded the software? Can you download? 把那个 link 给 link 我写了，我在 link 在那写字，按聊天 ，OK， link 在这写下。So I give the link. 在哪呢？
John, most of us are familiar with WinStep, so if you can give us a freeware for your Rush Guangzhou, so it will be wonderful. Maybe we can test it here in Indonesia.
Okay. So now ask our computer engineers to demonstrate the software. Okay. 等会儿。对，这什么走不了？这不在这儿吗？往前走啊，走不下去，真的。Okay. So I think that's this is the we say test equating of MET. You see, so we use Rush Guangzhou to conduct test equating for MET. So and then I will give a very brief, you see, introduction to the research and the test equating we conducted, you see, for matriculation English test, you see. And in China, for example, we have many national-wide examinations on large scale, yet with high stakes, you see. You see a lot of big, large-scale examinations. So MET is one typical examples. And the features of MET, first is compulsory. All the Chinese middle school students must take MET if they want to study in a university or college. Yes. And it's high stake. Means if you take the participate in or you take the MET, you fail. You cannot, you see, enter university. And it's a unified and national level. It's only one test paper administered across China, you see, at one time. So mostly we have multiple choice questions, plus you see 50%, you see, writing, you see a test. Writing is the writing of English given a topic, and usually approximately is within 150 words, or no more than 200 words to explain or to discuss one topic, you see. So we do test equating, you see, from 1990 to 1999, you see. Personally, I'm the person who in charge of conducting test equating, you see. We use this software. And one thing worth mentioning here is that equating in China, in Chinese situation, is something we say different, you see. First, you see, as uneven development of education and the big number of candidates, I mean test takers, taking the test, the population is actually heterogeneous. Means China is a big, you see, usually students along the coast provinces are much better because they have better, we say, how say, means the southern part, or it's usually, we say, better than northern parts. Yes. Okay. And difficult to set an unbiased test. So that's why we have to do the item analysis, you see, let alone to equate two parallel test forms administered on different occasions to different students. All the test papers were centrally set, means we write test papers, meaning we're a small group of professionals. We gather together in Beijing and we write test papers. But there was no way to score, mean to grade the test papers centrally. So usually the general practice was to assign each individual province to grade its own papers and to work out its own norm for recruitment. This made university authorities confronted with the problems of selecting, you see, students whose scores were graded according to different criteria set up by different provincial departments of examinations. So that's why we should test equating. So after we rescale the test items, so we can get the students' ability. The ability parameter can be further converted into the scores, so they can be comparable on the same scale. So in China, there's no feasible way to protect test security once test is administered, nor it is possible to use common items in different test forms, nor is feasible to conduct any pre-test for future use. So that's why you see in China we have parallel tests, so we use common item linking, common items linking. So to find feasible solution to such problems, we established an anchorage, that is 3 sampling bases. We use some middle school as a sampling basis to monitor the performance of the candidates, the students. We design an equivalent test papers. That's equivalent test papers is 35 actually are the linking items. Then the other 65 are test items. We mix them together and then present it to the test takers 3 days before they take the real test papers. So such an equivalent test forms was used repeatedly for 10 years because you see students, they don't know which, you see, test items are actually the link items. They don't know. So they will give equal attention to all test papers, you see. And also, then the data we obtain will be more reliable. Okay. So in doing so, we could not only observe, but also compare the performance of candidates taking MET in different years because all test papers took the test very seriously and data thus obtained are very reliable. So our hypothesis goes like this. There will be no big change in terms of general means, I mean English proficiency, within 1 year's time if there's any change of means, it must be associated with the change of difficulty level of test forms across different years or 2 years. Okay. Then we came to realize that such a hypothesis is by no means perfect, or at least for at least 3 reasons. First, the sample size. We're going to risk of test leaking. The sample must be big enough to be representative. However, the larger sample, the greater the danger of test exposure. So we cannot use that. So I've used linking items, okay. Next, the general level of population, I mean the students' population, is not likely to remain unchanged. Instead, it is actually fluctuate. So we should say the insignificant changes may accumulate into significant changes, you see. So finally, there's no any changes in terms of difficulty level of test forms, you see. If there's any change in terms of the difficult level of the test forms, it would not be accepted by simply making any linear adjustment based on individual test scores. You see, you know statistics, so linear is not reliable, you see, regarding the difference between the test forms. So we use anchor test random group design, like this. That's 1 year test students, they take MET. Then next year different students take different MET papers. We establish linking items, you see, with, you want to ensure that no test leaking. So we mix these 35 linking items with the other 65 test items. We use as a test paper. So into this, we say, into this one test paper. And then the test paper is administered separately. We do not put the link items in any of the test papers. Did I make things clear? Idea clear? So that means, and this is, we say, equating test paper administered to students 3 days before they take the real MET. So each year, students must take this test. Then you will take real MET. And for each year, we collect the data, then we do test equating. Make sense? And then we'll have a discussion, we'll tell you, okay, I'll tell you, okay. So the equivalent test was actually administered separately 3 days before MET was actually administered. So I think you can see the ideas. Okay. So let's come to summaries, okay? So first we're sampling. I'm the person, you see the person go to the schools to collect the sample data. And then we administer the equivalent test. We use, you see, chi-square test to process, to check these 35 linking items. You see, if it's appropriate, we keep it. If it's not appropriate, especially the discrimination index is not good, we delete it. See, so for example, in 1989 we have 28 items. Then in 1990 to 1991 we have 27 items. So 3 items are not good, so we deleted them. And we have equating test forms. The test results, for example, of 1988, you see, that was the year when MET was first administered across China, was used as a basal reference. You see? So all the test papers administered in the following years would be equated to this basal test. If you see the result indicates that it's typical basal test papers, that score will be just rescaled, you see, increasingly. If indicates that it's a little bit lower than, you see, the Bayesian test forms, then the scores will be also adjust, means decreasing. So in this way, we keep test scores fair to all the students in different years. Okay. Now this is not our practice. This is a practice by Ben Wright. You see, I suggest you read another book. It's called Best Test Design, written by Ben Wright. You see, that this part is actually we borrowed from this Ben Wright. Okay, but we put them in our program, not only talking. You see. Okay, then we have ability estimation. You see. So in the case of Rush model, the ability estimation is straightforward. To obtain the maximum likelihood estimation of theta, we use the procedure, proposed by Hamilton in 1985. You see, the ability values are again converted into probability for those who know nothing about Rush. You see, so this we have the students' ability parameters will be converted into the probability. For public, that means for ordinary people, they know nothing about the parameters. We have to use the simple numbers to the student parents or the ordinary people to know what we are doing. As the model has the sample free feature, we could make use of the derived data to obtain adjusted scores for the population. Okay. Okay. And also another question, why we use Rush model, not the other models? Say IIT models, you have 2 parameters or 3 parameter models. So here, as briefly, I should say, we just use Rush model. Easy. And easy means even use big data, you see, the programs, they have an iteration and it's easy to come to convergence. You see, if we use 2 or 3 parameter models, we did use them, but you see, sometimes it's difficult to come to convergence, so the programs abort. I think even though statistics, you know that. Okay, so we use just, you see, feasible implementation is easy. Okay, for example, a candidate getting a raw score of 60 correct answers out of 85 test items will be assigned an ability value, regardless of which combination of the 60 correct answers. In the case of 2 or 3 parameter models, these procedures get complicated. Means they will get, you see, very, very big numbers. You see, so the estimation is very much associated with the discrimination and the so-called guessing parameters. Therefore, the 2 or more candidates getting a raw score of 60 correct answers out of 85 test items will be assigned different values because of the combination of 60 correct answers vary from person to person. You see, even though IIT know that, you see. Okay, so imagine the combination of items from 1 to 84 is a huge, it's very big number. So impossible to use the sample data to predict the population performance. So that's why we just use Rush model. Okay. Very often the iteration, I say, never come to convergence. So yes, so we just use Rush model. So that's why also we put Rush model in our programs only. Okay. So according to Ben Wright, you see, with Rush model, items and ability fit can be computed, and we can demonstrate the degree of goodness fit of the model. That's it. Okay. So now we want to demonstrate this program using the data to show a complete procedures. Okay. I use this computer engineer to do this for you. Okay. You can. This is the logo. 咱们看就对。OK，
还没看见，还没共享。
有共享吗？共享了。Okay, now that's the logo of our program, please. Okay. Use Indonesia. Okay, Indonesia.
Selamat datang di sistem analysis butir dan penyataan tes ras Guangzhou.
停一下. It's easy.
Sistem ini
Okay.
terdiri dari dua.
Professor Bamba, it's easy to understand.
Yeah, absolutely. Maybe you can share the freeware for us so we can test it for our student. Thank you, Prof. Zhang.
I mean, it is Indonesia because this is an artificial language. It means generated by the machine, not by us. Okay. It's easy. Could you understand it, for example?
Yeah, sure. It is in basic Indonesian, so we easy to understand.
Okay, 你看人家听得懂。Okay, please, okay. 继续，把它听完，刚才没听完。
Selamat datang di sistem analysis butir dan penyataan tes ras Guangzhou. Sistem ini terdiri dari dua bagian utama. Bagian analisis butir digunakan untuk analisis klasik dan analisis model ras. Bagian penyataan tes digunakan untuk analisis penyataan. Bagian semua file output memungkinkan Anda melihat semua hasil analisis serta mencetak atau menjexper keyword.
I think that Indonesian accent is a bit different.
Okay. Now we import two, you see.
Okay.
This is the first test paper's data. Okay. Okay, please. Okay. Then once we import data, if the data is fit to the format, immediately we get the 4 output files. Easy. You needn't write any computer files. You see, that's the we check each one. Okay. 4 output files. Okay, so this is the basal test, and the basal test say we have 100 test items, and for each test items we have parameters. This is item analysis for each of the test items, right? Okay. Total will have 100. And this, we say the basal test, this is the first output file for basal test. Then we have text next one. second file. Here. That's the second output file. You see, we have this is very important. We say table. You see, we have this is the we say the discrimination. This is the difficulty. You see, this is the we say the two-way. It's got p-value means different level, and we said discrimination index, the two-way table. It shows that you see, for example, this is theoretically for each test paper, we should have a normal distribution. You see, for very difficult items, they should account for 5%. And for difficulties, 15%. For intermediate, 60%. Easy, 15%. And very easy, 5%. So totally we should have 100 items. That's their total. And for the, you see, if it is a normal distribution, theoretically, you should have at least 5 items which are very difficult, 15 items difficult, and so on and so forth. But when we analyze this test paper, it indicates no difficult items. And difficult items, there were 76. And for intermediate, only 22. And easy items, 1. Very easy items, 1. So total is still 100. Then, whether the test items are appropriately designed or can be accepted, you see, no. For very difficult items, no. And for difficult items, only 26 items are good. And for intermediate items, only 7, 1. So though you have a test paper consisting of 100 test items, only 34 items are well designed and can be accepted. So that's the finding. Then that's all the parameters. That's you understand it, okay? That's Indonesian language, okay? Then we have further, you see, results. And for very difficult items, this is the listening part. Very difficult items, no, because they are below, you see, 0.3 discrimination. And there are 26 difficult items, and there are 17 are not good. They are listed here. These are the number of the test items which should be either deleted or should be moderated. Make sense? And for intermediate, there are 12, totally 12, and 7 out of 12 are not good. These are 7, and this is 1. The same is for listening part, for grammar part. And for reading part. That's the correlation. Okay. That's different loading, okay? This is a second out of 0.5. Then let's cover the third one. Okay. This is the overall report of these basal test papers. You see? So this is Indonesian language, right? Okay. So you can understand it. Okay. It's easy. This is a summary, actually summary of the basal test papers. Let's come to the fourth one. And the fourth one, the fourth out of vial is difficulty parameters based on Rush model. You see, and totally we have 100 test items. You see, that's difficulties. You see, or possible scores. You see, that's difficulties. And with, you see, this well calibrated test items with the difficulty based on Rush model, test equating is possible. Means we can do test equating. You see. So this is a normal distribution. This is actually test items of the basal test papers. You see. So it's try to say it's a little bit easier. Okay. Okay. This is the we say the ability. Also the person, right? Is person. And this is similar, like wing steps is similar. Okay. Now we have some explanations here. There's curve of test takers, right? Okay. Okay. Now with this, actually we can do test equating. And with the first three ones, we can moderate test items. You see, to ensure each of the test items is good, or we can either delete it and we have new added or more, you see, well calibrated items. Okay. With two, you see the output files of Rush model difficulties. We can do test equating. So that's the second one. We can do similarly the second test paper. Yeah, about the network problems goes slower, okay? Yes. Then we import the second test paper data from second test paper. We are doing the same thing, just press button to get the similar 4 output files. Okay. Okay, 这 rush 嘛，这 Basil 那个呢？把那个拿出来，这 Basil 把那个。对，这个是对，不对，这个是 equated 嘛，对 ，equated 对，就是打进来行 equated 是分手，转了。Okay. Now you see, we got two. You see the output files from two different test papers. This is a Basel test. This is an equated test. All they have the items. Then when we import these two these sets of data, sets of parameters, then we have some results saying that one, this is we do the chi-square test. We do chi-square test. Then we decide how many items you will use as linking items. You can use any number of any. So for example, we use 20 items as linking items, actually anchored in two different test papers. Then we do chi-square test. Okay. Just click. Then we'll get these 3 items are not good. So we automatically delete it. You see? So it means 3 out of 20 link items are not good. So they will automatically deleted by the system. Yes. Then we have to test equating. You see? Then this test equating is done. You just press button. You know, test 1, test 2. That's the rescale test. You know that's in the Indonesian language, so you can understand it. Okay. There's 20 items in red, indicates they are used as leaking items, and the others are the test items which have been rescaled and which can be comparable on the scale. And also, they also indicates, you see, the difference in terms of difficulties is minus 0.0066. That means the basal test is minus 0.066 difficult than test 2. In other words, you see, test 2 is a little bit difficult than test 1. Because that's a rescaled, okay? 这个是让它这个完整发挥。我们看这个曲线，两个曲线，看这个曲线。So then you can check the curve. You see, yes. The curve. Okay. This is the basal test. You see, it's a little bit easy. Yeah. Yes, that's next time we'll put them together. This is the basal test, technique test. Yeah. If we compare, this is a second test. You compare, you see, it's not, you see, they have only a few, you see, the test items, you see, in this area is actually a little bit difficult than the first one, you see. So we can, now you see, that's the whole process of test equating. Then you can use these parameters, you see, to adjust your test scores, you see. But in China, you see, up to now is our job, you see, as for to confirm the ability into the specific scores, that will be done by the examination bureau, by center, not by us. Okay, I think that's all for the ideas of testing item analysis and test equating today, you see. So thank you for your listening.
All right. Thank you very much, Prof. Zhang. So very wonderful to see the work of your software, right? Some students already informed me they are very interested to test the software. So if you don't mind, maybe you can share with us the what we call as the freeware version. I think some
Yes.
of us see the potential. So for example, maybe ECA will be used for the what we call as continuing tests with different what we call as time situations, right? So I
Yes.
think also, yeah, I think people like Nurul, Dwi, Umam also can use it, the software in terms of repetition of the test, and can what you call automatically have the information in terms of test equating and linking. Before that, usually we use it manually. Okay, we run into WinStep, got the informations about logit, then we do it one by one, which is sometimes takes time to doing it, right?
Okay. Yes.
And yeah, Prof. Jangs, I think hopefully next year when we meet, so I can got the free copy of your excellent books.
Yes. Yes. For this book, it's now, you see, officially published. You see, also,
Oh.
you see, You also in the book. You saw.
Oh, okay. Yeah, sure.
And you see all the the prompts this year. Prompts the conference was held in we said Surabaya.
Yeah, Surabaya. Yep,
Yes,
yep.
was you see presented, and also your university and your staff members also are mentioned everything. You see.
Okay, excellent.
Yes.
Thank you, Prof. Yang.
Okay.
Right.
So another thing you see, Professor Bamboo and all the participants, I sincerely hope you download the software and use it. Give us some feedback. Okay.
Okay. Sure.
Okay. Thank you. Okay.
All right. Okay. Now I think the question and answer session, Prof. Some student maybe want to ask some certain questions. So if you don't mind, okay. So anyone to
Yes,
ask
please.
question first?
Okay, please.
Anybody? Right. So just raise your hand. All right. So Munaya here want to ask the first one. Okay, go ahead.
Okay, thank you for the opportunity. Am I clear, Pak Prof?
You.
Okay, so thank you for the presentation, Prof. So based on my understanding that test equating is applicable in the large assessment, so it's really useful for that. My question is, so the test is unidimensional or multidimensional? So if it is multidimensional, so how do we place the item anchor? So is it need to be evenly distributed in every dimensions, or how the deciding to decide the item and anchor?
Yes. How said that? You mean? I'm sorry. You mean what kind of dimension? What does symbol dimension?
So maybe the test is mathematics, so we have like different dimension or aspect like that, Prof.
Okay. You see, this software means this can you say analyze all the test data of all the test papers, not English test papers only. You see, mathematics or physics and any test papers, so long as they have the dichotomous data only. You see, if you want to have the polytomous data, then you can use the other software such as Pascal. Pascal is good for more or less data type. You see, and we just use the dichotomous, the yes or no types. You see, again, not only for English language only, or for any language, or no, for any test. So long as you can get the data of yes or no questions data. Thank you.
All right. Thank you, Munaya. So next one, Umam. Go ahead.
Yeah, thank you so much, Pak Bambang, also Prof. Quan for the presentation. It was amazing. It's really something new. But my question is, I just wonder, like, whether this app can be used, let's say, for analyzing or equating like the classroom questions, which sometimes limited in number of the item. Let's say they have like even for binary, it's only, let's say, 30 or less than 100 questions, because in your examples you have like 100 items per sections, let's say, for listening and also reading. Let's say if I use that to analyze the classroom assessment practices, which is limited in number of the item, is there any problem with that, or is there any limited number that should be included in the analysis? Thank you.
Okay, thank you for your question. I think now our program is actually compatible with Excel. So we can process unlimited number of test items by unlimited number of subjects. This is no problem, you see. Another thing is that we can process two types of data. One is the data type we showed, you see, we demonstrate is A, B, C, D. That's a chart, Professor Chart. The other is also said dichotomous is 0, 1, 0, 1. You see, we can also process this type of data, both. So for a chart, data of charts, you need to provide key answers. So if this the integer data like 1, 0, 1, 0, you see input 1, 0, 1, 0. You needn't provide any so-called key answers. So that will be easy for you to process data. Did I answer your question? I'm sorry.
Yeah, that answers the questions, but I have the follow-up questions. What I want to know as well is about like, is there any limited items that should be inputted? Let's say at least for the analysis to work well, it has the minimum item, let's say 100 in your example, or let's say around 20 or 30 is okay for the number of the item.
Oh, I see. Yes, usually you see theoretically, if link item is more than one, means at least 2 items or too many. But usually people would say is the number of link items should be only 10% of the total. Make sense? Yes. And because
Yes,
you see, we have some experiments that shows that if you use 2 link items and 20 link items, the difficulty of the parameters generated, there's no much difference. Make sense?
Right.
But it's highly correlated.
Yes.
Okay.
Thank you.
Oh yeah.
Thank you.
All right. So Umam, remember that we are comparing 2 test papers. So I think Prof. Zhang emphasized that at least 10% of the item is similar. So
Yes.
bigger than that is better. But of course, if similar, so there is what is the point of test equating if all of them item is similar, right?
Yes.
So, but Prof, the next one that Umam mentioned is it okay to have less number of students?
At least 40. The minimum
least
sample
40.
should be 40. But of course, the
Okay.
bigger, the better, you see.
Yeah, I think
Yes.
Umam, that's the take-home message. So we are handling the dichotomous data. So Prof. Zhang mentioned that at least 40 students participate in both test paper. Right.
Yes.
So next one, Ridwan, and then after that, Fani.
Okay,
Yep,
thank you.
go ahead.
Prof. Zhang, excuse me, I want to clarify that the first you show in the slide in the early slides that this RAS Guangzhou is using the different models for processing the item analysis and test equating. Would you explain to us even though you are already demonstrate the use of the RAS Guangzhou practically, but you said in the presentation that the item analysis you're using CTT and the test equating you are using RAS. That was my first question. And the second one, you are already demonstrated to compare for equating to instrument of test. What if I have more than 2 tests that need to be equating?
Oh, yes. Good. Okay. Yes, I will answer your second question first, you see. And theoretically, if you set the basal test, then you can actually equate as more, you see, test papers as you like. You see, if you set 1 as a basal test, then you can connect at least 2, 3, or more test papers, so long as you have the same link items anchored in the following test papers. But you see, our experiment shows that if you have more, you see the test papers. So sometimes, if the data or is not too good, or so on, for some other reasons, it cannot come to convergence. So the best way is that you have 2 or 3, I mean 1 basal test with another 2 test papers, will be easy to come to convergence. And also, if it's not very big, that they say it's 100 test items is okay, you see. And if we use the other softwares, it cannot come to convergence. Or if you use more parameters, it cannot come to convergence because you have so many, you see, we say the factors or variables to interact and so on. You see. So, excuse me, what is your first question? Thank you.
In your presentation previously, you are introducing us to the RAS Huangzhou, and then you state that the item analysis on the RAS Huangzhou is using the CTT model, and the test equating using the RAS model.
Yes.
I would like more explanation regarding this basis. Why do you use use CTT on item analysis while you are using why the RAS Hangzhou is
Yes.
using RAS on test analysis?
Okay, because you see, for item analysis, usually people use classical testing theory to do item analysis, because classical testing theory means we cannot conduct, you see, test equating use CTT. But you see, this can you see the slides? You see, these are the only items parameters you see generated by classical testing theory. That will be good to ensure, you see, each of the test items be well designed. You see, especially we have some very simple statistics like this discrimination index, and you see, so how to say that? You see, only we have the well-calibrated test items, and with these well-calibrated test items, we can, you see, obtain the better or reliable difficulties. Make sense?
All right.
I said it again. Okay. No, I said again. You see, if all the test items are poorly designed, you see, so even do the test equation is pointless. You see, make sense? Yes. For example, you see, yes, you have 100 test items, but actually they are not well designed, and so that the scores obtained from these test items are not reliable. So it's not meaningful or significant to go further to do test equating. And also another thing is that rush model we cannot use rush model to conduct item analysis. And another thing is that if you use Bilog, you see, if you use Bilog, you can omit this part, because Bilog can, you see, if you use 2 parameter of IRT, it can we can obtain both difficulty and discrimination index. You see, that's the good point. The disadvantage is that sometimes you see, if you use 2 parameter models, so it's not easy to come to convergence. So the programs would abort in the middle, if in case, especially in the case you use big data. That's my experience. You see, I also I've been using Bilog Pascal for many years, and then when we have a curve generated by the data, we use the same data. You see, use 3 different programs to process the same data: Bilog, Pascal, and Rush-Guangzhou. And the curve, the parameters they generated, highly correlated. So that's why we decided to use Rush model only. Yes.
All right. Thank you, Prof. Zhang. So I think, okay, for Ridwan, so this is what you call is relying on one measurement model is not enough. So you need the RAS measurement model, for example, in terms of probability of correct answer, delta, do some kind of linking and then equating. All right, Fanny, next one.
Thank you, Dr. Bambang. Good morning, Professor. Thank you for your presentations. I'm really interested to learn more about RAS Guangzhou. In terms of WinStep, we know that WinStep is provided for analyzing two facets like person and items. And we also
Yes.
know about the many facets applications, which we are going to analyze more than two facets. So I'm just wondering, what will be in the context of RAS Guangzhou in terms of many facet in the item analysis and also item equating? Is it possible to use a RAS Guangzhou? Because I don't see that one in your presentation, or maybe I don't still not really seeing in your presentations about the many facets in terms of RAS Guangzhou. Thank you, Professor.
Okay, thank you for your question. I see, you see, but you see, frankly speaking, and our program can do test equating, you see, via rush model only. So we don't have that similar function of facet, you see. But frankly speaking, facets you can use for my personal knowledge, you see, can use to analyze the different raters, you see. They have the specific parameters split, you see, or separation, you see.
Yeah.
So different from ours. So and
Okay.
our programs is good at conducting test equating, you see. I think that's
All right.
my answer. Thank you. Okay.
Thank you,
So if we
Professor.
want to, yes. So first is I know that different functions. Okay. Thank you. Okay. And also again, I should say, you needn't write any control file or command file to do any analysis. But if we use the facet or WinStep, you have to learn how to write a program. You
Coding
see?
and
Yes,
yes.
thank you.
All right.
And
Okay.
also, you
Thank
see,
you,
again,
Pani.
another thing, our program can speak your language, Indonesia.
Yes.
Thank you.
Yeah, sure. If you can share to us, we are very happy to test that program, right? And then we will what we call this can give you this testimony, and then also we will mention in our report. Don't worry, Prof. Zhang. So, any last question you want to ask? Anyone? Anybody?
And for Professor Bamba. So on the screen, you can see slide. You can see my email address.
Yes.
Yes.
Right.
So you will
So-
ask your participants to send me email if you like. And then also now you can download free. You see, we're good friends. It's free. You see, you can download. So I sincerely hope we can
Excellent.
download our program in Indonesia and do the analysis. Give us feedback. See, okay? Yes. Next time when you come to Guangzhou to attend, prompts conferences, we are invite you for tea. Okay, cup of tea. The local customer.
Okay, thank you very much, Prof. Right, so I think all of us already heard from Prof. Zhang. Okay, so you can email or WhatsApp, no WhatsApp. So I think WeChat. So China is a bit different in terms of instant messaging, right? And then you can request about using the software. Yeah, especially if
WeChat.
you.
WeChat is okay.
Oh,
WeChat.
all right, yeah, but we are not really familiar with WeChat, and then in terms of what we call register to WeChat, so sometimes most of us have difficulty because need to confirm by what we call is already registered WeChat. Also, but email is okay, Prof. Zhang, right? So
Okay.
anyway,
Okay.
so thank you very much, John. So for a very nice introduction of your software, RAS Guangzhou, and then also to share with our student, and also the some of them come from outside Triple IU also. And I think we learned so much here from you in terms of the differentiation of using test linking and equating using RAS. Okay. And then, yeah, I think Prof. Zhang already shared the software here. Okay, you can see from the chat room, right? And then, any last word you want to say, Prof. Zhang?
Okay.
John, you want to say something?
I'm very happy, you see, to share our software lecture with you. And really, I'm very happy because, you see, I really do want you to come to attend conference, you see, 2026, Guangzhou, China. Then we can have more, you see, discussion. And if you have any questions, do send me emails, okay? I think, you see,
All right.
we have very good, you see, lecture today, I think.
Okay, thank you, Prof. Zhang. So, those of you who have papers about RAS, so next year FROMS will be in China, in Guangzhou, also on June or possibly on June 2026. And then all of you are welcome to register and to attend. And Prof. Zhang will have some specialties to share there, right?
Sure.
So thank you very much all for coming and then sharing Prof. Zhang to us. And then I would like to close and then thank you very much and see you in the next occasion for the guest lecture. Right. So bye everyone. Good morning. Thank you, Prof. Zhang.
Thank you. Yes. Yes.
Thank
Thank
you,
you.
Prof. Zhang.
Thanks
Thank
for
you, Pak
attending.
Bambang. Have a good
Yes,
day.
thank you. Bye. Bye. Have a nice day.
All right. So I will close the Zoom meeting. Okay. Thank you.
Thank you. Okay. Thank you.
Thank you, Pak Bambang, Prof. Zhang. Thank you.
Okay. So I leave. Okay. I leave. Okay.
Yeah. Yeah.
Yes. Okay. Thank you. Okay.
Okay. Bye, everyone.
Thank you, Pak Bambang.